video we will discuss that how can we calculate the Fourier transform of cosine wave. Let's suppose a cosine wave is given by having this half portion of the wave which varies from minus pi by 2 to pi by 2 with an amplitude a. So we can calculate what is the time period, because this is the half of cycle, so then we can say that t by 2. So t by 2 is equals to pi by 2 plus pi by 2, the answer is pi, and the total time period of a complete wave if you have another portion of this wave which is equals to 2 pi. So we can say that the signal is equals to a cos omega t. And from here we can see that omega is equals to 1. Why? Because omega is equals to 2 pi f, and you can calculate the value of f which is equals to 1 over t, and the value of t is 2 pi. So if you insert 1 over t in this equation, you can say that the value of w is equals to 1. So you can insert 1 here, so then you can write the signal is equals to a cos t. And we know that the formula for the Fourier transform x of w is equals to integration minus infinity to infinity xt e raised to minus j omega t dt. We will insert xt here, that is a cos t. So then we can write the limit, because the limits of the signal is from minus pi by 2 to pi by 2. And then we know that the cos theta is equals to e raised to minus j theta plus e raised to power j theta divided by 2. So using the Euler identities, we can convert that format into this format. A is constant, you can take the constant out, and cos t is equals to e raised to minus jt plus e raised to power jt divided by 2 multiplied by e raised to power minus j omega t. So then you can again simplify that formula. A by 2 limits of the integration minus pi by 2 to pi by 2 e raised to power minus j 1 plus omega t plus e raised to power j 1 minus omega t dt. And then you can take the limits integration separately, like first this function, so the integration of that is this one, and then the upper limit and the lower limit. The integration of that part is that one, and the upper limit and then the lower limit. So you just insert the upper limit here minus lower limit here. So this is minus, so that is why minus, and then the lower limit is minus, 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 plus. And similarly here you insert the upper limit and lower limit, and then you will end up with this signal here. So if you multiply this negative with this function and you multiply this 2 inside, so this 2 is here 2j, and then this 2 is here is 2j. So this negative is gone upward, so that is this minus is minus, and this minus multiplied by this minus, it becomes positive. Okay, and similarly this 2 is multiplied by that 2, and then you can further simplify this with that, like sine 1 plus omega pi by 2, and then sine 1 minus omega pi by 2 using the Euler identity, because the sine we know that sine theta is equals to a raised to power j theta. Like if you are use this formula, then we can say that okay, sine theta is equals to e raised to power j theta minus e raised to power minus j theta divided by 2j. Okay, so this portion here, this portion will be equals to sine theta. Similarly, this portion here will be equals to sine theta. So using that Euler identity, we can further simplify that one, like that will be equals to sine 1 plus omega pi by 2 and 1 plus omega. Similarly, sine 1 minus omega pi by 2 divided by 1 minus omega. To make it more simplified form, we will further multiplied the denominator with pi by 2, both denominator with pi by 2, and then multiplied the numerator with pi by 2 as well. Okay, then we can write this format in this format as well. And we know that SA is equals to sine t by t if you are considering the sampling values. Like if you consider the sampling in the signal, then you can write SA is equals to sine t divided by t. So we can use this formula, and then the simplified version of this equation will be equals to